The first topic we cover in the expressions chapter is how to evaluate expressions. Evaluating expressions is where you replace a variable with a value to get a number answer. Kind of like in video 1 when we replaced the F in Fahrenheit with 64 degrees and then figured out what 64 degrees Fahrenheit converts to in Celsius. Or when we find the area of a rectangle, you replace the length and the width with the numbers that go with that. It's the same idea. I am not going to do all of these evaluating expressions. I will, however, put the work. So if you want to go back, pause the video, and work through the work, you may. A couple of hints. Sometimes using parentheses helps. Sometimes it becomes cumbersome. But if you're dealing with lots of negatives or exponents, you may want to use them. I'll show you some examples. Don't forget to use order of operation. So let's look at this example. AB minus A squared. Again, remember that when A and B are right next to each other, that assumes multiplication. So A is negative 4 and B is 2. Just replace the A's and the B's with negative 4's and 2's. A is negative 4, so A times 2 minus, now here, A is negative 4. I want to replace A with a negative 4. I'm going to put that in parentheses. For a couple of reasons. First of all, I don't want to get mixed up. I want to understand that there's one negative from the formula and one negative from the number I'm subbing in. I don't want to miss that. Second, when you have a variable squared, you want to make sure that the negative sign also gets squared. It's a good reason to put parentheses in. Now we'll just use order of operation to solve our problem. I'm going to first do the squared. Negative 4 squared. Negative 4 times negative 4 is 16. So I'll replace that piece with a positive 16. Remember, this negative sign from the formula is still there. Next, order of operation tells me to multiply. Negative 4 times 2. That makes negative 8. And I still have my minus 16. Negative 8 minus 16 is negative 24, our answer. Evaluate negative A squared if A equals 5. I sub in the 5 instead of the A and I do the problem. Remember from last module, order of operation tells us we have to do the squaring first. 5 squared becomes 25. Then you add your negative. Negative 5 squared with no parentheses is negative 25. Evaluate negative A squared if A equals negative 4. So I've got a negative from my formula. I've got negative 4 squared. Now why did I use parentheses here? Because it wants me to square A. If A is negative 4, that means the whole thing should be squared. So I have one negative from my formula, one negative from the number I subbed in. I'm going to do this piece first. Negative 4 squared is a positive 16. Then I make the answer negative because of the negative from the formula. I want to do one more example. Let's evaluate A squared if A is equal to negative 4. Notice that's almost the same as the last problem, but not quite. There's a negative in this formula and not in this one. A squared if A equals negative 4. That means I'm going to sub negative 4 in for A. Notice my use of parentheses. I want the whole A value squared. So the whole A value is negative 4. I have to make sure that the whole negative 4 gets squared. Negative 4 times negative 4 makes a positive 16. Again, I'm not going to do the next two examples, but if you want to pause the video and look at the arithmetic for them, you may. I would like to look at the last one. A minus B divided by C minus D. A is negative 2, and B is negative 3. Notice my use of parentheses here. -2, that's the number that goes in for A, minus, I want to make sure I get the minus that comes from the formula and the negative that comes from the number I'm subbing in. I can't skip one of those. Now, when I'm doing my order of operation, I treat a fraction bar like a parenthesis. I'm going to do what's on the top and what's on the bottom and then divide them. So -2 minus -3. Remember that when you subtract a negative, that's the same as adding. So what I really have here is -2 plus 3 on the top and 1 plus 1 on the bottom. -2 plus 3, think money, lose 2, win 3, that's a gain of 1. And a 2 on the bottom, 1/2, or 0.5. Math books a lot of times do these problems with just a whole bunch of letters. I don't really like that. It makes you feel like this isn't a tool that you will ever see or ever use. Where evaluating expressions really comes in is in real life word problems where you have to use a formula to sub in. One place in your near future where you will see a lot of evaluating expressions is in a statistics class. In fact, beginning algebra is a prerequisite for a statistics class for exactly this reason. Now, there's going to be a lot of stuff in here that you don't understand what the variables stand for, but that doesn't mean you can't do the algebra of it. For example, the first one. This is actually finding an average, but you don't need to know what any of this stuff means, only that you're going to put in 4, 5, 7, and 3 for x1, x2, x3, and n. So you sub those in, you add up the top, and then divide by 3. So our mu, our mean, is 5.3 repeating. Again, we don't need to have any knowledge of the stats behind this to be able to do the evaluating expressions, the arithmetic behind this. I've included another, a little bit scarier example. Don't let this scare you. You don't have to do this if you want to. But my point with showing you this is that all I'm doing is taking my numbers and putting them in for the variables. So even this nasty looking thing here, all I'm doing is taking, whenever I see that, I just put this in its place so that I get something like this. Now again, the arithmetic on it is horrendous, but the idea is the same. You're just plugging these things in and simplifying to get an answer. You do not have to go through this arithmetic, but I put it here in case you're curious. Here's another stats example dealing with z-scores. Again, you don't know the statistics behind this, but what I want to do is zone in on the algebra of it, on the evaluating expressions. Find x if x equals z, which is 0.4, times that little doohickey, which is 0.02, plus the funny looking u, that's a Greek letter mu, which is 6.5. So we multiply 0.4 times 0.02, get 0.0808, and then add 6.5, so we get 6.508. Again, using evaluating expressions is something that you'll come across in a lot of different classes. Here's a biology example. Anytime you have an equation. Now I'll help you get these numbers. The biology classes where they would teach you where these numbers come up and what they mean. So the growth rate of a bacteria is 52% each hour. That means that your R is 0.52. Initially there are 2 bacteria. The P stands for principal or initial value, which we're going to put in as 2. N is your time, 3 hours. And your A is your amount. So we want to know the amount of bacteria after 3 hours. Again, this is the stuff you'd cover in the biology class. But what you should know from your math class, from your beginning algebra, is how to sub this stuff in. and how to work the arithmetic to get an answer. Do what's inside the parentheses first. Next, take your exponent. Remember that right here, there's an invisible multiply. Approximately 7.02 bacteria will be present after 3 hours. Anytime you see an equation in real life, in a class, and they want you to put numbers into it, that's when you are doing evaluating expressions.